This is section 10A, conic sections. Graph x squared plus y squared equal to 9. Let's see what you guys got. Let's see what you guys got. Let's see what you guys got. So, I don't. So let me just go ahead and let's go ahead and do something. Let's try to figure it out. So if we don't have a graphic calculator, maybe we just try to plot points. So let's go. Yeah, let's do a table of values. So usually I tell you to use these numbers. What? -3, -2, -1, 0, 1, 2, 3, 4, or whatever, like those numbers here. In this particular case, I'm going to do it a different way. If I told you, well, because I already know what we're looking, what good points we could get. If I told you x is 3, what is y so it satisfies the equation? Anybody? 0. So if I plug in x is 3, this would be 3 squared is 9. 9 plus 0 is 9. So y better be 0. And we can go ahead and graph that point. That satisfies this equation. If x, what would be, now hopefully you see a pattern of what I'm doing here. If x is, say, no, let's go with y being 3. I'm going backwards on this one because this is not going to be a function. If y is 3, then what is x? 0. That's the way, okay. Or I could have just said that if x is 0, then y better be 3. So, yeah, I could have just said x is 0, y is 3. If x is -3, what is y? 0. There's people that are lazy and you put something like this down and you think it's -9, and we already done this, and I told you when you plug in, you better use this. It's +9. So that is going to be +9 plus. So this x is -3, 0. X is -3 is 0. And what could have been again if I go back and say y is -3? Yeah, let's go with, if y is -3, x is what? 0. So just the same when we graphed those sine functions and we had some points, and I told you, well, for all you know, is you would want to connect these dots and go, well, just connect them and go like this, and it makes like a diamond thing. And I will already, did I put it on the wrong one? You would get some kite looking thing or something, and I'll tell you it wouldn't be correct. Why? Because I know it wouldn't be correct. Let's get another point. Let's get another one. Let's test another one. You guys got calculators. Let's test something. Why don't we test -2? If we do plug in x is -2, x is -2, this is x and this is y. If x is -2, what is y? Okay, let's go. Let's keep testing some points here. If x is -2, what is y? Plug in x is -2, that makes it 4. 4 plus y squared equals 9. Minus it to the other side, it's going to be 5. Y squared equal to 5. Square root of 5. Y equals, you guys all got calculators? What's the square root of 5? Square root of 5 is 2.23, 2.2, about 2.23, 2.23, negative 2 goes to 2.23, and I will tell you it will do the same thing over here, and it's some kind of symmetry like the unit circle, so it's going to be somewhere like right here, and somewhere maybe over 2, they said, and somewhere 2.2, somewhere here, and then you'll see that there will be some points going like this, and you see some points going like this, and you guys see it? You guys see it? What is it going to make? Yes or no? So when I was saying here, and I was conic sections, all right, let's go over here. Conic section means that the Greeks, was it the Greeks? The Greeks, they would study cones, and they would have a cone like this and another cone like up there. So you have 2 cones, but we're not going to study one of them, so I don't need 2 cones. I just need 1 cone. Yeah. So if I get, say, some flat surface or something like this, and I cut this, if I cut it right directly horizontal like this, we would create this shape right here. What shape is this right here? It's a circle. And if you get and if I go like this, I get this, and I cut it at an angle, like this, go right through it, it will create this other shape. Sorry. What shape is this? It's like an oval, no? Yes, like an oval, and that oval is called an ellipse. All right, we're going to do that on Monday. We'll study. And this one right here that dropped, if I would have done it, looks sort of broken, so bad. So if I would have just cut this one right through like this, and then would have created this shape right here. This shape is going to be something going like this. What is that? An upside down what? Parabola. It will be a parabola. We're not going to study parabola. And the last one would have been, like I said, if it would have had 2, would have had 2 of them. One on top, because it's 2. One like this, another one like this, and then we would have cut it like this, right through like that. It would have created this. And that's called a hyperbola. We're not going to study that. We're not going to do that. I used to go over that, but now we don't. So that's going to be conic sections. That's what we're doing. Conic sections. Here, look, the general equation of a circle. Now you know that it kind of looks like the Pythagorean theorem. A squared plus b squared equals c squared, but it's really just now instead of a, it's the actual x on the x on the coordinate plane. The y is b, it's the up and down, and this is going to be, what do you think? Okay. What do you think 9 is then? What was it? Wait, let me go back. Where'd it go? Oh, no, go back. Undo. Yes, all right. Look. What is the length from here to here? What is that length? 1, 2, 3. So what do you think is the length from here to here? 3. This is a circle. This is a length of 3. So the radius is 3. So basically what we're doing is this. This is x, and this is y. So this is going to be x squared plus y squared equals the radius squared. And that is the equation of a circle. So then this is going to be x squared plus y squared equals 3 squared. This should be 3 squared, where this is the radius of a circle. It's centered at 0, 0. You saw it. It was at 0, 0 with a radius of 3. All right. As we continue, I'm going to do this. You drew it. I have this question for you. If I tell you that I'm going to make an angle here, you guys see it, this theta here, with respect to try and say angle. What would be the angle? This point is A, this is B, and this point is C. What is the angle? Go back to geometry, this angle ABC, which angle ABC is theta? What's the angle theta? What is the major angle theta? Well, no, maybe that's not a good question for right now. Let's not do that. Let's Let's have another question. Because then that's going to require something extra we don't have. Let's give you this question better. Go ahead and write that down better. Given that, so I'm telling you, given that I'm telling you that sine of theta, sine of this theta, is equal to 0.6, then what is cosine theta? Let's see. Given that, they're telling you that sine theta is 0.6. Then if sine theta is 0.6, then what would be cosine theta? Let me give you some time to you guys. Why don't you guys go through this process of thinking it through? You become, I hope, more mathematically mature. You know a little more math. You got a little more tools in your toolbox, mathematics. You can figure it out. It can't be just you teaching me. Let's go try to figure that out. What do you think if I tell you that sine theta is equal to 0.6, then what would be cosine theta? How can we figure that out? Let's see, like sometimes, yeah. And does anybody have any ideas on how to even do this? Anybody? Okay, hold on. Let me, because I want, there's definitely not just one way to do this. I know two ways. And so and I want to know how people think. You said what? So make a triangle here? Well, that's fine. Where should I make it here? Sure. No, let's make a triangle here. No, let's go ahead and do that. Let's do that. So that makes this. You said 90. Yeah, it has to. I mean, this is straight up and down. This is on this, so it has to go straight up and down. This is 90. Come. Yes, it is 90. What else? What else can we do? O over H. This okay. O over H. Oh, it's not 3.
So I'm gonna.
Then we got a problem. But at least there's a thinking going on where I'm like, oh, but we run into a problem. Why do we? Because we're missing this part. We do got a problem. Anybody else can think? See, this lesson or this warm up is more about think about everything you know that are facts that we can do. That was correct though, I think, what you were doing, but maybe you could have done something else though. See, I could leave it there. Let me leave it. Let me leave it. This is true. All right, let me give you something. You should never really assume anything, but because I made this thing, I will tell you. Oh, definitely. What is this though? What is this? The length. What's the length of this? Well, it is -2, but it's a length of 2, and so we know that length. It's -2 for the direction it went that way. And so what do you think this is? What would you assume that it is? 1.5? And I tell you that I was meaning to say that it is 1.5. But I shouldn't just give, since I made it, I'll tell you that it is 1.5. Or else, how the heck are you going to do it? So then that is 1.5. This is -2. -2. Anybody now? Can we figure out what this is now? Can we figure it out? Yes or no? How? Why? How? Pythagorean theorem, thank you. This is -2. This is 1.5, then you can figure that out. Go ahead and do it. You got calculators, go. Figure it out. What is it? What? Is it? Is it more? I don't know. You guys, look. If you need to participate, I know there's too many people just sitting waiting for answers. If you're not participating, doing what you for 2.25, 2.25 plus 6.25. It's 2.5. 2.5. 2 is 2.5. I can't be up there just doing this stuff like that. People just looking at me good. This is 2.5. Yes or no? Because you did a squared plus b squared equals c squared. Yes or no? Is it or is it not? Okay. So if that is true, then there's an answer, wouldn't it? Tangent theta is what? What is, oh, not tangent, but cosine theta is what? What is the definition of cosine? See, I need you to tell me, not like teacher, you tell me. No, we've done too much trick already. I shouldn't be teaching. So it's going to be what over what? We said what? Adjacent over hypotenuse, and it should be what? -2 over what? -2 over? And the answer should be what? Huh? Okay. All right. Now. That is correct. We got it. Let's see. But I have this other proposition for you. We got it. That's the way to do it. What's my other proposition? Here's my other proposition to you. This was given to me, all right? We already got this point A. But this was given to me. Sine theta is equal to 0.6. But what is the definition of sine? What is it? Which is going to be, let's go opposite. This is opposite over. And what is this up? Yeah, what is this length which I said? Because I told you that that's what I was intending for it to be, 1.5. Yes or no? Yes? Okay. So, is this true anyways? So it's supposed to be 1. We did the Pythagorean theorem, and it would turn out to be, what was this when you said 2.5? What is 1.5 divided by 2.5? Does it matter? What is 1 point? Because that's what it's supposed to be. What's 1.5 divided by 2.5? 0.6. Oh, it is that. What else was I going to try to do? Sine theta is what? Y over R. And then cosine, what is cosine theta again? We said cosine theta is what? X over R? All right, let me see what I'm doing here. We already solved it. I'm trying to do it this other way. So we know that 0.6 is equal to y over r. And I told you that y is what? Y is, well, it's 1.5. Y is 1.5. And so here, cosine theta is, what is cosine theta? This, say without using this 2.5. I'm trying to solve it without the 2.5. Say we don't know what r is, and I don't want to do that r. Say just do this. So 0.6 is equal to 1.5 over r. This is not r. What is it going to be? See how this is r, but that's not what I want. I want this. This would be c for the Pythagorean theorem. You see that? So okay, so let's say c. This is not r. This is c. All right. So 0.6 is equal to 1.5 divided by c. Cosine theta is, what is x then? For the triangle. I'm talking about triangles. The x is what? Negative 2. Can I solve for c here? Can I solve for c here? Because that's the only variable, no? I'm going to times it by c and then divide it by 0.6. Where c is, they're going to switch spots. 1.5 divided by 0.6. So c is 1.5 divided by 0.6. Yes. C is 1.5 divided by 0.6. Is it? Get your calculators. What's 1.5 divided by 0.6? Huh? Wasn't that what we did with Pythagorean theorem? I'm just trying to get you to like expand your mind and understand this is so, everything is so connected in so many different ways. So if that is true, I am not even using the Pythagorean theorem like this. I'm not using Pythagorean theorem. So then if that's what this is, then it's going to be negative 2 divided by 2.5. What is that? What do we get? It's the same. I'm going to tell you right now, and then after I stop the video, that sometimes they're not exactly the same answer. And so, well, I'll tell you. I'll talk about that later. Anyways, we're good to go. Let's go next. What is the length? B. What is the length of the arc itself? Self-tens? What is this length? What is this length? What is the length of that? What is the length of that? I did not go over it on finding arc length of a, like that, of parts of a circle. But the formula is like this. Let me give you the formula. So the arc length will equal to the length of this arc. Let's see, does anybody know what would be the length of this arc? Of that part of the circle? This arc of the circle. What would it be? It will be the length of the radius, but the whole, all the way the radius, times theta. So it'll be r times theta is the answer. R times theta. So r is what? 3. And if we knew the theta, then we would just multiply by theta if it's in rads. So if theta was what? I don't know, I'll make up a number. If theta was pi by 3 or something like that, then I'm making up, no? Say it was pi by 3, the angle, 60 degrees. then you just multiply 3 times pi by 3. Yes or no? Make sense? So cancel would be pi or something. I don't know. Yeah. Yeah. So the formula is r times theta gives you the arc length. Okay. But we don't know what this theta is, so if we knew it, then we would just get it. So for right now, it's 3 times theta, whatever that theta is. All right. Let me give you. Let me ask you another question. If the circle was not with a radius of 3, but the circle was actually the unit circle, and the unit circle is the one we'll be working with. This is the unit circle. This is the unit circle, because the unit circle has a radius of 1. So if theta, if I ask you, hey, what is the angle? What is the angle? Yeah, even of this one, yeah. What is this angle? What is the length of this angle? Anybody? The answer would be what? 1 times theta, which would be exactly theta. Yes or no? Because the radius is 1, so you just be multiplying it by this r is 1, so it just be theta. So if it's the unit circle, this would be exactly, the arc length would be exactly theta. If it was a smaller circle, if it's a smaller circle, what would be this right here? It would be less. It would be less, wouldn't it? It would be what? It would be a fraction of this theta, no? Because it would be less than 1, no? Yes? Yes? All right. So let's continue on then. Continue on. Let's go. C. Let's do part C, and then we're going to continue on with the lesson. Part C. If a spinner starts at the positive x-axis and it spins 50 radians counterclockwise, on which quadrant does it land? And then how many full revolutions does it make? So this makes me think about where I emphasize what I teach and what I do with where I don't really emphasize in what I do. So I know that most of you guys would have a hard time with this because you don't even know, like, what's a radian? What's 50 radians? What exactly is all that? So you understand a spinner will start at the positive x-axis. We'll put a spinner here or spin the bottle. Let me draw a bottle here. So you play spin the bottle. Here's my bottle. All right. So you're going to spin that counterclockwise. Clock is like a clock goes down. Clockwise. Counterclockwise goes up. So we're going to spin it that many 50 radians. 50 radians. The problem we have is what the heck is radians? So, what's a radian? What's a radian? Do you remember when I went from degrees to radians? Do you guys remember when I did this? For any circle, the length of the radius, okay, so that's the radius for this circle. I'm going to grab that thing and I'm going to go around this much. That's one of them. That's 2 of them, and that's actually a radian. And that's 3 of them. And there's some missing right here. What is this missing right here? How much is this that is missing right here? 0.1416. If you were good, and I'll be like, yes or no? For any, this is going to be what? 1 radian. This is what? 2 radian. This is what? 3 radians. Yes? 0.141. So this is going to be how many radians? This is what? Pi radians, yes? And then all the way around is how many radians? 2 pi radians. 2 pi radians. So now, I'm telling you that this is a radian. So now that is a radian. How many degrees is actually a radian? How many degrees is that? Well, how many degrees is that? What's the angle of that in degrees? How can we figure it out? How can we figure out how many actual degrees this much is? About how much? You say what? Very close, actually. Because it would be 60 if it was what? 60, 60, 60, it'll be 180. But it would go what? Because these are like equal parts. But it's not 60. Let me see. 60, 180. It's going to be less than 60 degrees. How can we figure out what it is? How can we figure out how many it would be? How do we do that? So 2 pi, let's see, pi is what? Pi is what? Let's see, pi is, how many radians is pi anyways? Okay, how many degrees is pi? Or what is pi? We said pi is what, 3.14? Which is 3.14 on and on and on radians. Pi is equal to 3.14 radians. Pi is equal to how many degrees? 180? Yes or no? Yes, pi is 180 degrees, yes? Oh, somebody tell me how to find the degrees. Why don't I divide both sides by pi, no? But where pi is what? What is pi? Pi is what? 3.14? Divide 180 degrees by 3.14, and that's going to give me how much is 1 radian in degrees. So divide 180 by pi. Hey, make sure that your calculator is in rad. You're going to get all messed up numbers if you don't use that it's rad. So, well, in this one, you're going to have to use degrees. Or better yet, because this is in actual number here also, actual number, just divide 180 by 3.14. It doesn't matter in this particular one. What's 180 divided by 3.14? What is it? 57.3 degrees? You were close. The answer is 57 degrees, 57.3, 57.3, 57.3, 50.7.3, and then whatever that is. Oh, yeah, let's calculate what this is, the leftover in degrees. I just thought about it right now. 3 times, okay, what's 3 times 57.3? 171 point, what, 171.9? Yes? So what is this missing part in degrees? Get your cal. What's 180 minus 171.9? It's close to about 10 degrees, no? A little less than 10 degrees. All right. One circle has how many radians? 6.28? 6.28. 2 pi radians, which 2 pi radians, 2 times 3.14, which is 6.28 radians. Isn't that going to give it away now? Do you guys see it now, how we can figure this out? So what, everybody? If I spin something, I start here, and I go around one time. I go around one time. How many radians have I gone around? How many radians have I gone around? Yes or no? And if I go another 2 revolutions, how many have I gone now? 12 point what? Yes or no? You get it now? What's going to happen? So what would be a best way to do it? Couldn't I just divide 6.28 into 50? Ah, smart. Good Chicago learners go 50 divided by 6.28. So 50 divided by 6.28. What is that? What are you getting? 7 point what? 7.96. All right. How do we interpret that? How many revolutions did full revolutions did it make? 7. So if a spinner starts at the positive x-axis and it goes around 50 times, we'll figure how many full revolutions does it make? It makes how many full revolutions? And what's the leftover? 0.96. So on which quadrant did it land? 4th quadrant is correct. If it would have been this, if it would have been 7.65, which quadrant? Just cut it into 4. You know, 20. If it would have been what? 7.24. Which quadrant? Anything between what? 0.25 and less? 0.25, it will be the tough one because right there in the, no. Yeah, it would be right there on the axis actually. 7.50 would be what? On the 7.75 would be, and then 8 or where. So anything in between, it would actually land on these angles, on those what are they called? Quadrants, no? So all right, let's just in general. If we would have been, all right, you know what? Let's do another one. We already got this as an answer. Let's make up another question. Well, that thing is what? 7.96 spin 7 lands on the 4th quadrant. All right, last one here. Change that 50 to what? Give me a number. How many radians? There's an infinite amount of numbers you can choose. Somebody give me a number. Give me a number. We're going to spin it, not 50. Give me another one so we can all work it out. Let's go. Give me a number. 23? 23. Okay, let's go 23. Go. Do it. So change this. If a spinner starts at the positive x-axis and it spins 23 radians counterclockwise, which quadrant does it land and how many revolutions does it make? All right, with 23 radians, how many full revolutions does it make if it spins counterclockwise? Huh? 3? In which quadrant does it land? On what? Third? Third. I'm thinking it's third, yes or no? Yes? Maybe or maybe not? You think yes or no? Why? It's between what, 0.5 and 0.75? All right, let's finish the lesson now. This is the general equation of the circle. X minus h squared plus y minus k squared equals r squared, where h and k will be the center of the circle. So, center of the circle is equal to whatever h and k are. Yes, h and k. R is the radius. Find the center and the radius of each of the following circles. All right, let's go. Blue is not a good color for this background. Which one is a good color? Definitely yellow is a good color. Yeah, leave it like that. Oh, I have not printed that out. Yeah. Who's that going to be here? Becky, so what's the center? What's the center? The center of a circle, center, I erased it, will equal to h and k. Center will be h and k. So what's the center of the circle in this one? I don't know. Everybody, what's the center? Do you guys remember horizontal is opposite of what you think? That's what I kept saying when it's a horizontal. But it's going to be weird though. It's weird. Why? Well, this one is going to be left 3. And this will also happen here. The up and down for these circle ones, this one's going to go to the up to. Yeah. For circles, it does opposite for both x's and y's. So it'll be -3, +2. What's the, Maria, what's the radius, what is the radius? Look at the equation, look at the pink over there. What is R? Loud. I don't know. It says radius squared. So how can you write this down as radius squared? R squared is 35, so it's going to be what? You can just square root of that number. Square root of 25 is 5. The R is 5. Number 2. Stephanie, what's the center?
-5, 2.
-5, 2 is correct. Evelyn, what's the radius? Wow. Close. Close. Probably less than that. I think it's less than that. A little bit less than that. You could just leave it at square root of 38. But it would be close to what you just said. But it's less than that, though. I don't think that's pretty good. Let me do it. So, square root. Square root. Give the square root here. What the heck is the square root? Let me turn this on. Square root is 38. What the heck am I doing? Square root. Oh, it's over here. 6.2. 6.2. About. Okay. Another one of my favorite problems. I got favorites. I have favorite problems that come up here and there. What's the center? Man, if you can get this one, I'm just gonna move you to like college or go to this too. You can do all this in your head. No, we have to work it out. We have to put it in this form. We have to do this. We put it in that form or that particular form. It's not in that form. We got to do some work. Okay, let's do it. Here are the steps. Get the x's together next to each other. Get the y's next to each other. And move that constant to the other side. Get the x's next to each other, get the y's next to each other, and move that +4 to the other side. And we're going to complete the square. Get the x's, x squared minus 6x, y squared minus 2y, and we're going to complete the square. Extra credit to whoever can tell me right now. I will put it in the computer. I've been doing a lot of extra credit in my other class, and I don't like doing it, but what goes in this box to complete the square? Raise your hand quickly. Did we not do this in chapter 3? Let me do this. So, so there's these algebra tiles that in 8th grade they like to do a lot of manipulatives. They call it manipulatives, where this little red squares. Am I gonna go get them? Where did I put them at? I think we've done it before, where x squared is a red square. It's an actual red square. It doesn't look like a square. It's all messed up, but it's a square. Because they say that x times x, this is called an x squared. So that is an x squared. And then I have these little sticks. So I got the little sticks. 1 times x is x, so the stick is called an x. So I got 1x squared. I got 1x squared. Red because it's no, this should be positive. It should be blue. It should be blue because it's positive. Yeah, well, yeah. Let me put it blue, or let me green. So it's a positive 1x squared, so it should be green. And I got six red sticks. And what I'm gonna do is I'm gonna complete the square by putting one. It's red. I'm gonna put one of these red sticks here because it's a negative, and I'm gonna put one here, and that's 2, that's 3, that's 4, that's 5, that's 6. And then there's those little baby squares. You know, there's little tiny little squares. You guys ever seen those little? Yes or no? Yeah. So this I said this is x, but these are negative. That's a negative, negative ones. Negative 1 units of negative 1, negative 1. The length here, negative 1, negative 1, negative 1. So it's going to be a negative times a negative equals a positive. A positive, little tiny little squares here. And that completes the square. That's what it's called, completing the square. And that makes it a square. So how many little tiny squares did I need? 1, 2, 3, 4, 5. I'm gonna have to throw that one away. That's not a square. Can I stop? Am I messing around? How many is it? Huh? 9? Is it ever gonna be negative? Is it ever going to be negative? Because it's always a negative times a negative equals a positive. So now, is there a way to not take like 5 minutes to do something where it should take like 3 seconds? We're going to split this into half on the bottom, half on top. I know the answer is going to be positive. Negative 6 divided by 2, and then I'm going to square it. It's called a square. What's negative 6 divided by 2? What is negative 6 divided by 2 is what? Negative 3? And what's quantity negative 3 squared? What's negative 3 times negative 3? Let me see. Raise your hand. Who can tell me what was in this box here? Raise your hand. No. Damon, what is it? Huh? What? Yeah, what goes in the box? What the heck? I was playing around really with the. That was so easy. You're not paying attention. Or? So what happens is that so in 8th grade, a lot of teachers use these little manipulatives. They're called like little squares. Sometimes they're red and sometimes they're like yellow. Little red, yellow squares. Red and yellow squares. So. Oh, but that's a Y, huh? You're getting confused that it's a Y. It doesn't matter. It's still squared. So anything that's squared, it'll still be. Let's use it blue then. Let's go with blue square. Where in this one we have a Y times a Y. Like, can numbers be colorful? Like that's a red. So it's a number times a number that's the same. That makes it a Y squared, no? Makes it a Y squared. And then mostly this negative is that makes it red. The negative is the one that makes it red. So you have so what is this? You got like two red Y's maybe? One goes there, one goes here. Well, yeah, that's a negative y, and a negative y makes a negative 2y. Yeah, that we have a y squared, a positive y squared, which is this one, and we got one negative y, one negative y, and then what? And so what's the little what goes here? What is here to complete the square? To make it a square, what goes there? Huh? It will always be positive, because it will be if it's a positive times a positive, you will get a positive. It will be a negative times a negative, you will get a. It will always be a positive number. So you should never worry about being positive negative. So that is a 1 squared, one little tiny baby squared. So that's a unit of 1. So how could we do this faster? How can we do this faster? So the formula goes that you get a quantity square, you're going to get the b value. Let me give you the formula. B divided by 2 squared. That's the actual formula. And this is called 1 is A, B is negative 2. That'll be C. So we are trying to find C. C. Look at a happy face. No, is that happy? So it would be what? C is going to equal to what? B is what? B is what? What is B? So it'd be negative 2 divided by what? Bunch of 2's everywhere, huh? Negative 2 divided by 2 is what? Then what's negative 1 squared? Now actually some people are like, I don't know, is that negative 1? Negative 1 times negative 1 is what? That's what it had said. Now here's the extra credit question. What goes in this box here? That is a good question. What goes in that box? The mystery box. It's a mystery box. What if a clown comes out of there? What goes in that box? What? Who said what? 10? Why? Yes, I like what you're thinking. Yes, because it would make it unequal. If we say something is equal, how can you put things on one side and then not make it the same here? So the equal, it got to be 9 and 1 is 10. That is correct. That is correct. What now? You're like saying, what now? I don't know. What's the next step? So, it's going to be in the video. So I was trying to get a job at Central High School, some high school, and they were like, how do you do factoring? And I was like, I like to do the X method. Let me show you. Like, show me how, what. See, what I do is I do this. I don't like that color. What I do is I do this. Like, what is that? See, it goes, the middle number goes to the bottom. First times the last of these numbers. 1 times 9 is what? 1 times 9 is. And then you do a little T-chart and figure out what 2 numbers multiply to 9. Multiply to 9, add up to, multiply to 9, add up to what? Negative 6? So what are those 2 numbers? What are 2 numbers? Negative 3, negative 3. Let me see. Negative 3 times negative 3 is positive. Negative times negative is positive 9, negative 6. Yeah. So we got what? X minus 3 times X minus 3. Yes or no? Yeah? Is there a better way to write that down? Isn't that X minus 3 squared? More efficiently compact? Yes? But there's two of them. Don't do this. Don't do this. Oh, I'm taking back. That's like the people trying to hire me. They're like, don't do that. That's childish. Who are you trying to teach? The way to do it is, when it comes to conic sections, it will always be the quantity squared. Square root of x squared, x. Square root of 9, 3. And it will always be the middle sign. If this is negative, then this is negative. If this is positive, then this is positive. Gotta stop, man. I do have it. I do have the. I still have my x here, and maybe I should get rid of it. Maybe I should, but I'm too lazy to change it. Still have the x. Can we do the quantity square already? Can we do quantity square? Or you're like, no, I like the x. So what is it going to be? You better not say x. You're like, but why is it white? Isn't it blue? Okay. I don't like blue. What sign goes here? What number goes there? Oh, you already said minus. What you doing? Subtract 1? What the, you don't? Square root of 1 is Brian. What's the center? Oh, he's not even. He didn't hear me. He's into music.
Oh shit.
No. I said Brian.
Oh.
But he ain't even trying to. Oh, you're not even paying attention. I'll remember that. I'll remember that. Huh? I'm not loud enough? I said, what's the center of the circle? Okay. What's the radius? Anybody? Just say square root of 6. 2 point something, what is it? 2 point something, no? Let's go. Why don't you guys do it by yourself? Go. Do that one. I think I'm going to... Am I going to stop the lesson? Yeah, that was it. Oh, that's enough. All right, stop this.